critical Mach number. Very first, about Mach number, I go to whiteboard. You're supposed to remember about Mach number, right? Mach number, it's velocity and object that it's related to speed of sound. Correct?
Yes.
Yes, teacher.
Yes. Mach number, it's, we make it like m equal velocity of the object related to speed of sound, c. And because of velocity, by velocity, here we are going to have some unitless number. And this magnitude of this number, it depends on the velocity of the object, and also it depends on the speed of sound in this environment. So most of the time, speed of sound depends on the temperatura, ambient temperatura. ¿Por qué? Porque, example, when we know that it's air is gas, correct?
Yes, teacher.
Okay, thank you, Luis Roberta. It's a yes, okay, I need support sometimes. Okay, gas, air is gas, gas is like molecules, and we have some distance between molecules. And what happened? We know from physics that it's all these molecules, they have some kinetic inertia, these small particles, right? They have kinetic inertia. And as soon as they have kinetic inertia, they move, they vibrate, these molecules. And when we increasing temperatura, we are increasing kinetic inertia of these molecules, and vibration is stronger, it's more amplitude. Sometimes maybe more frequency, but more amplitude of the vibration of the molecules. And what happened? Like sound, when it's running on, like going on in some like environment, for example, in atmosphere where is gas, it's like physically or mechanically sound, it's just like a vibration of the air. So vibration of the air molecules, and how fast transmitted these molecules, it's making like how fast is moving the sound in gas, in atmosphere, in air. That's why when it's higher temperature, when it's ambient, higher ambient temperature in atmosphere, molecules of the air vibrating like stronger, and sound is moves faster in this ambient condition because of molecules vibrate stronger, and sound has like more velocity if we have more temperature. Formula that is describes sounds and temperature, speed of sound and in temperature is like that. It's equal 331.3 plus 0.6 temperature. Temperature in Celsius here, in Celsius, okay? And it's equal something but units is meters per second. So units meter per second.
Teacher,
Yes?
you're sharing a whiteboard?
Yes? Can you see?
No.
No,
Oh,
teacher.
I'm sorry. So here,
Aléjale y vele buscando, güey. Así estuve yo un buen rato.
Sí, quítale la ilusión porque está también ahí tú y yo.
No, pero no aparece la pizarra, no aparece el whiteboard.
can you see, Heriberto?
No.
No?
No.
Okay. Who has the same problem? Who cannot see me, my whiteboard? Okay. So, Adrian? Adrian? No connection. I don't know. Just wait. Adrian, can you hear me? Emmanuel, can you hear me?
Yes, teacher.
Emmanuel, can you see whiteboard?
Yeah, I can see it.
But see, Heriberto has problem. Adrian has like connection problem. I see he sent a message.
Beto, sal y entra, güey, a la conversación a ver si se puede con eso.
Simón, salí,
A ver,
entré y
sí.
eso. A
A
mí
ver,
me pasó
deja
lo
hacerlo.
mismo. Y luego te aparece arriba una cosa de abrir. Y ya nomás la abres.
Heriberto is going to sign in again, right? Maybe. Oh, no, here. Leslie, are you here?
Yes, teacher.
Can you see whiteboard?
Yes, teacher.
Oh, okay. Yeah, we just wait when like Heriberto going to fix his situation.
Yeah.
Can you see now,
Yeah.
Heriberto?
Yeah.
Yeah, okay, good. See, Heriberto,
Yes.
here, like Mach number, we know that it's velocity of the some object moving in air related to the speed of sound in this air. And speed of sound in air, it's not always constant. It depends of the factors. And this factor, the most important, is temperature. And how speed of sounds changing with temperature, it's this formula, 331.3 plus 0.6 of the temperature. And here temperature in Celsius. And this is speed of sound in meters per second. Not in feet per second, it's meters per second. So here we can say that it's, for example, velocity of the object, speed of the object related to the speed of the sound. And if speed of the, if the velocity of the object equal speed of the sound, so we can say here speed of the sound divided by the speed of the sound, and it's equal 1.0, and here no unit, right? Because speed divided by speed, velocidad divided by velocidad. So just 1.0, and this one is sonic. Sonic velocidad. Mach number equal 1 is sonic. Mach number less than 1 it's subsonic. Mach number more than 1, it's supersonic. So for now it's enough. Like remember, Mach number, if it's equal 1.0, it's sonic velocidad. Mach number less than 1.0, it's subsonic. Mach number over greater than 1.0, it's supersonica. Next, Mach, it's like in, just wait.
At high speed,
Okay. In English, it's MACH. Like I know my students here in Mexico, you read it in Mexican manner and you say Mach number. For my class, it's no problem. You can say Mach number. It just, it's not philology class, right? But remember, if you go to any international conference and you go like, if you present your, like your job like somewhere in international journal, remember in English we call it Mach number, not Mach, Mach number. Understand? So now if Mach number equal 1.0, we have like sonic velocidad. If Mach number less than 1.0, it's subsonic. More than 1.0, it's supersonic. Next, what happened here? Okay, I go to whiteboard. I move whiteboard. Next, I'm going to explain critical Mach number. Critical Mach number. What does it mean? So just imagine airfoil, asymmetrical airfoil. We have upcoming like some velocity here. Velocity infinity is upcoming velocity, right? And we know air moving on the top, air moving on the bottom. Now you know that it's air moves on the top, somewhere in front part of this airfoil, it's moving a little bit faster than here, correct?
Okay, teacher.
Yeah,
Yes.
teacher.
Yes. Just let's say in this punto, somewhere in this punto, velocidad moving faster. Let's say this velocity, let's say like we are using in like Mach, we are representing through Mach number. So Mach number like 1 equal, for example, 0.5. Okay, but this Mach number here is going to be Paquita mass, right? Mach number 1 is equal here 0. Maybe 59. I don't know how much exactly. It depends. It depends of the form of the airfoil. It depends on another condition. But here just logica. Just you're supposed to understand what does mean critical Mach number. Just imagine here upcoming velocity Mach number 0.5. At this point, where is maximum velocity? This velocity increases to 0.59. Next one, here Mach number equal 0.6. This velocity here, it goes to Mach number 0. For example, 7. Okay. Next, here Mach number goes 0.7, and here it's increasing to Mach number 0.85, maybe something like that. Okay, understand?
Yes,
Yes,
teacher.
teacher.
So
Yes.
next, just imagine, we understand logica, right? Here coming like air, and here on this punto, this air increasing its velocity. Increasing, like more velocity here, mass here, mass here, mass here, mass here, even mass here. Now it's jumping, just wait. Oops, like that. Now imagine that we have here Mach number equal 1.0. Ay. Oops. Wait, it's jumping. Oh my gosh. Okay, now it's stable, kind of. Now imagine, on the top of the airfoil, why it's jumping, huh? Leslie, it's you making this problem? Huh, Leslie? Why? I'm not even, it's just like back. No, I'm joking, Leslie. I know that it's not you. Oh my.
Okay, teacher.
Okay, it's here. Okay. See, just imagine on the right side, we have Mach number equal 1. And here, please pay attention. Velocity, upcoming velocity at which here on the top of the airfoil we have sonic speed, Mach number equal 1. This Mach number, this one, here, we call it critical. This Mach number is critical. and it can be like 0.8, for example. So now imagine here in front of the airfoil 0.8, here 1.0. This is critical Mach number right here. Here subsonic, here sonic, and it goes to supersonic. This is kind of paradox. This kind of conflict. ¿Por qué conflict? Remember, in general, what is difference between gases and liquidos? It's gases is compressible, liquidos non-compressible, correct?
Yeah, teacher.
Yes.
Yes. Now gas, air is gas, but just remember from like aerodynamic and physics of the air, even though that it's gas, but if it's compressible or not compressible, it depends of the how fast you are moving in the air. If your velocity of your transport, for example, your avion, like for example Cessna 188 that we have in laboratory, if you're using this avion and you're flying with like about 300 kilometers per hour, air moves around your avion and its air doesn't increase its density. It's, we say, for any subsonic movement of the object in the air acts as a non-compressible. Non-compressible. It's the same like if you take like a dagger, and if you cut mantequilla, like vertical, you're moving your dagger into mantequilla. Under this dagger, mantequilla doesn't increase density. Mantequilla just like goes like on two parts, right? Around your dagger, around your knife. But this is how it acts like avion. It's a knife, and air, it's mantequilla. Air just goes around avion. It doesn't increase any density. But when you go to sonic and supersonic velocity, now air starts to act as a compressible substance. And now the same like if you use your knife and pushing to the mantequilla by its flat side. Understand? Pushing flat side, you can see that it's under this knife, your knife, density of the mantequilla increases and it's moving on the side and it's creating some turbulence like vortexes. This one effect of the compressibility of the air. And what happened here, see, here velocity subsonic, in one point here, your velocity reaches sonic, Mach number 1, and when we get Mach number 1 and corresponding like velocity here, we call it this one, we call it critical Mach number. ¿Por qué critical Mach number? Because of at this Mach number right here on the top, velocity of the air goes to the sonic and supersonic. And because of here air no compressible, but here when it goes to sonic and supersonic, air increases its density. It turns to the compressible effect. And this is compressible effect, what happened? Like we have airfoil, and somewhere here air reaches like sonic speed, and what happened with air physically? It's like this shock wave, and this area of the high density air. ¿Por qué? Porque at this zona, air moving on the top of the airfoil, it compresses. ¿Por qué? Porque it reaches like limit of the sonic velocity and goes to supersonic, and that's why it's on the top of this airfoil. It's forming part of the air with very high density, and it's creating shock wave. ¿Por qué? Here Mach number equal 1. Here Mach number equal less than 1. And here Mach number equal less than 1. See? Subsonic, subsonic, and right here supersonic. And this one it making conflict. Subsonic, supersonic, supersonic, subsonic. And it's creating shock wave here. And what is physical result of this shock wave? This shock wave making very strong vibration and huge load under this structure. Oh, it's jumping again. Structure of the avion now experiences. Oops, it's disappeared. Sorry, people. Just wait. I'm afraid that I'm going to lose connection. Just wait. Okay. Ooh. No. Okay. So this zona, it's creating like shock wave, and for the structure of avion, this is very high load. It's physical load. It's creating vibration. It's trying to bend. It's trying to destroy like avion. Now just imagine, like we have avion, we have wing. Well, it's nice avion, huh? So what happened? It's not just in one punto. It's just in some linear, in some area. Here. And here also. On vertical fin also. Any part that has like airfoil former, and this is airfoil former, they like they have different airfoil former, correct? Even on the wing, from the raíz to the punto, we have in any this cross-section area, we have different airfoil formers. So different airfoil formers, this critical Mach number can reach not in the same time, in different time. Understand?
Yes.
So in
Yeah,
different
teacher.
time. So making this in different time on this left side, on the right side, what it does, it's creating some additional physical like stress for this structure of the avion, and it's a pilot. How pilot can see it? Pilot can see like vibration, increasing vibration. First appears vibration and increasing vibration. This vibration sometimes so strong that it can, it's able to destroy avion completely. That's why in Historia, when like pilots, they improved engines, and it was like velocity about 300, 400 kilometers per hour. And when appears first turbojet engine avion, and it was in 1943 probably. It was in Alemania, and this avion could easily go to 800 kilometers per hour. Can you imagine? 2 times faster than any other avions. And after World War II, like leading countries like Alemania, Inglaterra, United States, and Russia, they work on this new type of the engines for the avions, not propeller engines, aeroreactors. And all these countries, they understand that it's like they can go faster and higher in flight, increase altura and also increase velocity. But next step, engineers, they face two problema. And this problema was pilots reported that as soon as they are increasing velocity, all structure of avion started to have like a very strong vibration. And pilots, to avoid this vibration, they supposed to reduce velocity. As soon as they reduce velocity, no vibration. Again, increase velocity, when it goes to critical Mach number, it's increasing vibration. And especially what happened when in Inglaterra, this aeronautics engineer, he patented like jet engine, and he one of the first was patented jet engine in Alemania and in Inglaterra the same time, like in 1930s. And in Inglaterra, this aviation engineer, he decided to make like avion with new jet engine, with new aeroreactor, and to be first in human being history who is going to break sound barrier, to go to sonic speed and to supersonic speed. But what was problema? He just used the same formula of the avion, like traditional formula of the avion. He just installed aeroreactors, jet engines, and pilot was his son. And they decided to make it like very first in human being history, to make a record, passing sound of barrier of the speed of sound, to pass this barrier. And his sons started this flight. He took off avion, he increasing altura, he increasing velocity. When he started to feel very strong vibration, he reduced velocity, no vibration. Again, increase velocity. When he comes close to the sonic barrier, again increase velocity, and he tried to pass sonic barrier. He increased velocity even mass, and his avion destroys. And this pilot, he died. ¿Por qué? Porque structure of avion couldn't support anymore this kind of velocity because of this critical Mach number and because of this shock wave around all avion. And this shock stress destroyed this avion, and unfortunately this pilot died. And after that, engineers understand that it's something wrong, some conflict between form of the avion and the supersonic velocity of the avion. And they made, engineers made like a lot of experiments in wind tunnel, and they understand finally about this critical Mach number. So here in front, velocity subsonic, here in some part, sonic and supersonic velocities that creating very strong shock wave. And how to again jumping. how to handle this shock wave and how to fight with this shock wave. Aerodynamic engineers, they figure out why it's jumping. Aerodynamic engineers, they figure out that it's to fight against this shock wave, to control this shock wave, they have to do something with aerodynamics. They have to change forma. And after that, they decided to change forma of these avions, like wing, to make like this forma.
Excuse me, teacher. I'm sorry for interrupt, but are you showing a presentation or are we
No,
still in the
whiteboard.
whiteboard? I like what? Okay. I thought that was a presentation.
Can you see
Sorry.
whiteboard?
Yeah.
So just a second, somebody is talking. Here. Who are you here?
You received it?
Yes.
Okay, look, I'm going to speak with you for some authorization for the student because it's an email that you need a authorization for Dr. Erwin.
But I did.
Oh, yeah, you did?
Yes.
Oh, okay, there's no problem.
I did, and last week I got authorization for
Oh,
him.
okay, no, so that's good. Yeah, I just wanted to know if you have authorization because it's an email that is only allowed with some permissions from.
Yeah, permission for who?
Okay,
Yes,
okay.
Mr. Yes. Sorry, people. Okay. No, yes, I'm using this whiteboard, but it's not really a good tool. It's just jumping all the time. See. But next class, I'm going to show you like presentation in PowerPoint, but here I try to explain you like physical, what does mean critical Mach number, and por qué we need to change forma. And by the changing forma of the wing and forma of the airfoil, if you do airfoil like this, thin airfoil. Now, we can reduce this negative influence of the critical Mach number, but changing formula like this, making thin Chiquita airfoil, we are losing lift effect. But now to create the same magnitude of the lift, we have to increase velocity. That's why next step of the in aerodynamica, like avions make step to the increased velocity and change forma. But about these things, I'm going to explain you next class. And next class also, I'm going to show you some video. Maybe video helps us to better understand critical Mach number. Okay?
Okay, teacher.
Understood.
So this, it was like a whiteboard. I don't know, maybe some of you couldn't see anything, but still, this is only tool that I can use. Once again, next class, I'm going to show you PowerPoint presentation, same idea, same information, but with PowerPoint presentation. And next class, I'm going to show you some movie, better to understand critical Mach number. So, any questions, people?
No, teacher, thank you.
No? Okay, thank you very much for attending class today, 1 hour class. I have to run to laboratory or something over there. Once again, Friday, Viernes, we don't have laboratory class because still something with permission about laboratory. This coronavirus, it's making so many problems. So thank you for attending class. Friday, no class. So see you lunes, correct?
Correct.
Right, teacher.
See you
next week.
Lunes. And please stay home. If no necessity, don't go outside. If you go outside, use your mask, keep distance, all this like protections. And take care of yourself. Don't fight at home, and enjoy your life.
Thank you, teacher.
Thank you.
Thank you, teacher. See you.
Yeah, see you, Francisco.
See you.
Nos
Bye.
vemos.
Good morning, teacher.
Kevin, bye.
See you, teacher. See you,
Leslie, see you. Bye.
Bye, teacher.
Bye.
Bye, teacher.
Bye, Natalia.
Hi, teacher. Great week.
Israel, thank you.
До свидания, профессор. За
До свидания,
понедельник.
Израиль. Всего хорошего.
See you, teacher.
See you, David. Oh, ¿cómo está? Bien, ¿tú? Good. ¿Qué cuentas? I'm making all classes from here because from home my internet couldn't support this platform. Like when I start, no problem, especially in the morning when I start, no problem, and after about 20-30 minutes, it's just like it just goes off. I have to sign in again and again. It's not practice. Yeah, and that's why I'm doing here. Okay. And you, how are you doing? Yeah, good. And no COVID, nobody in your family, nothing. Oh, everything is okay. It's perfect. Actually, I'm drinking a chemical. Dioxychloride. I don't know if you know it.
No, it's a gas. It's some gas, but it says it's in the water. You can dilute it in the water. And there are many cases of successful for people who drink this gas.
Oh.
Actually, I make it in my house. I bought the ingredients, salts, and I make it in my house. That give me one of my brother-in-law because he saw many cases that improve fast, 2 or 3 days. People get it well. Yeah. But it's not accepted by the government. Actually, in Europe, it's prohibited. But I feel so good. I feel well.
Because this is fucking Chinese disease. It's never going to stop. It looks like
Exactly.
statistical down, up, down, up, down, up. Now it's again goes up. Right?
I've been seeing the statistics in Europe. It's
growing now.
It's actually more. It's higher this peak than the first one.
Yeah, but we will survive.
Yes, we still survive.
So you are coming sometimes here, right?
What?
Sometimes you come here, right?
Sometimes. No. I need some documents. But this is the third time that
I am almost every day here because of classes. Yeah.
Okay.
Yeah.
Okay. No.
Okay.
I hope you feel good.
Yeah, it's so far it's good. Yes, it's good.
You look very good.
Yeah, gracias.
But you gained some weight, right?
Yes, because no movement at all.
Exactly.
Yeah,
Me
just
too.
staying at home. Even just drink only hour, you just like, oh my God.
It's not fair.
Yes.
Okay, nice to see you.
Okay.